Alright guys, getting ready to do another test run on the gasifier with a revised, another revision on the water injection, the steam reforming direct injection nozzle thingy that we're developing. But we're over here at the EG4 because what I'm going to do is show you guys the amperage that the battery is outputting, and I want to go over some things about an inverter system when you're trying to figure out the amperage that that it's charging your batteries. And the one thing I want to note is when you input into an inverter with a charger and it has the onboard charger, it's designed so that you can do either a power generator or shore power. Now, the fact that you can hook up shore power to an inverter creates a serious issue with the electrical company. So there's codes and laws that they have to abide by. And when an inverter goes into charge mode, it has to cut the battery power off. Okay, so when you're setting up, say like I wanted to charge my batteries at 20 amps, and then whatever battery system you have, it's going to be roughly 54 volts. Is kind of a medium voltage that you can use for calculating your total watts. Because I have a 48 volt system, so it's charging from 48 volts to 58 volts. So 54 is actually a little bit higher than halfway. But anyways, so you have to factor that, but you also have to figure your wattage that the inverter is outputting on top of that. Because the power that the inverter is supplying is no longer coming from those batteries. They cannot do that. It's against the law. So when you're factoring that, don't forget to factor what it's actually outputting live on top of your charging output of the onboard charger. So I wanted to come in here and take a look at this because I can't get that screen to show up, and I'm hoping this will. So right now it's showing 18 amps, and if you notice, it's not a negative. So when I go into charge mode, this should actually change to a negative. So we're gonna come back in here after we have the generator back up and running. We're gonna come back in here and take a look at that. So that should change to a negative because the power is actually going to be going the other way. I'm going to start out at 20 amps, and that's something else I'm going to change on these next test runs, is I'm going to start upping my amperage. So for every 10 amps that I set the charger for, it's about 500 watts, 540 watts. So at 20 amps, it's just over 1,000 watts, about 1,100. And then with the shop running and everything, that's adding about another 700 watts. So it's it'll range anywhere from 1,700 to 1,800 watts. That my total net energy is coming from the gasifier. So I'm going to up that to 30 amps, and that should put it at around 2,200, 2,300 watts, so 2.3 kilowatts. So we're gonna go outside and get and I'll show you what I changed on the steam injector. So we'll take a walk out there and we'll get started with that. Alright, so I got the kiln up and running, so hopefully it's not too smoky out here. Just did a video on that, on some tips and tricks with that, but Anyways, all right. So basically, all I added, if you remember in the last video, it seemed like it had stalled, and we had talked on the Drive on Wood forum what's actually happening, and basically the steam is being superheated, so it's dry, and you just can't see it, but I could hear it, but I can't leave nothing alone when it's like that, because I'm afraid it's stalled. So I started playing around and trying to get the water to flow, and I did get the water flowing again, but I should have just left it alone. And what I did here is I added a little check valve. All right, so what this is going to do is this is going to keep steam pressure from backfeeding my water tank. And the idea is this will self-regulate the flow once everything's up to temp and everything's working. So basically it's going to fill up, it's going to convert to steam, create back pressure, closing this valve so no water can come in, and then once that's depleted, water will come back in, refill, and then it'll start converting to steam, and then close this back off. And then that's going to eliminate all this fiddling around with this valve here. You're going to start it out, of course, reserved. Let it get up to temp, and then once you got it up to temp, then you should be able to crank this open, and it should just self-regulate, and you won't have to mess around with this no more. And if that works, this is going to become a standard feature on the machines. I'll be moving to this this development, and I think this is actually a pretty groundbreaking deal. I had thought about doing this in the past, just never got around to it, but I decided to give it a try, and here we are. So, all right, so I'm gonna set you guys down and get the torch and get this thing fired up, and we'll see what happens here. I don't look all that great. It's like just under 9.5 inches. So just under about 5 3/4 gallons. Or I'm sorry, again, I'm always thinking in gallons all the time. 5 3/4 liters. All right, so that's what we're starting out with our water level. Got a fuel fall hopper. Alright, fire this thing up. Don't laugh at my socks. I earned this. Once you get over 50, you can do that. You can wear your socks. Pretty soon I'll have my shorts pulled up to my chest. Alright, so I'm going to take a look in there and see if I can get the water to flow with that check valve. It did flow when I tested it, but it's about a quarter turn open. Do not run that blower to try to sustain a flare. If the gas is low though, it's lit. This isn't designed to look at the pretty flare. It's designed to run that. So think of that thing like your car starter. You don't sit there and crank your car starter over for 15 minutes. You'll destroy it. So just keep that in mind. All right, so I'm gonna prime it. I'm gonna make sure it's on this time. Now there's air in the system, right? So once that air mixture gets right, it's actually going to fire, even with that closed. I think I mentioned this before, but if you got a generator with the eco mode, turn that off with a gasifier. You don't want to run that. If you're running this type of system, you're going to be battery charging, so you want to be loading this down as much as you can. But you also want to be self-sustaining, so that's what we're going to be doing partially with this video, is finding that threshold. So I got eco mode on. I'm going to turn it off. Hey. Alright, so I have my water dialed down to just a trickle for right now. I want to get this thing up and good and hot, and then we'll turn that water up. So we're going to go inside and have a look at the inverter. Here's a development project we've been working on for a client in Denmark. Alright, so let's see what we got here now. Alright, so it's showing 20 amps. But what's weird is I'm not seeing it reversed. Let me turn our power. So this is our power in right here. So I'm going to turn that off. You can hear the generator change. I don't know what's going on here, because that actually shouldn't. I can't see all that well. I wish I had my glasses. Alright, so I'm going to power this up. It should load. And you can see where it cut the power, right? So you saw what happened there. The battery cut down to 0, but yet my power in here is still on. So the transfer switched power from the input going out. Okay. Yeah, because if the grid is hooked up to that, you can't have battery going into the inverter, inverting out the output and you could possibly electrocute, one of their employees. If there's ever a power outage and you have a system hooked up to the grid, it's not good, right? So keep that in mind when you're factoring in your power. But I have it set for 20 amps, and that's about what it's outputting. 19.999 is just about 20 amps. Okay, and then unfortunately I can't really show you because it's just gonna look like a green bright blob. But yeah, I can check the output. Let me do that real quick. All right, so on leg 1, I'm at 532, and leg 2, I'm 250, 260. So about 800. Yeah, I'm about 1800 watts right now between the two, because you got 20 amps times 54 volts, so it's like 1100 plus the 800 watts that the inverter is outputting. So roughly 1900 watts right now. Now I'm gonna go in here and I'm gonna change it. So I'm gonna go to my settings here. All right, so now we're gonna go to 30. And then also, your inverter's got 2 modes. It's got like your charge mode, and then you got a float mode. If you change your amperage settings, you have to do it in 2 places, not just one. You have to change your float mode too. And I'm gonna just go, oops, I gotta redo it. So I'm gonna change my float mode to 30 amps as well. And that's a pretty reserved amperage for these batteries. So it's just going to charge at 30 amps no matter what. Alright guys, so I'm just going to let this thing run. Well, actually we'll see what happens here. So right now it's still roughly 20 amps. Alright, so now it's ramping up. Generator don't seem to even care. $32. Alright, so it's leveling out right under 30 amps. So now we're at about 22, 23, maybe 2400 right now. And at the end of this run, then we'll calculate how much charcoal fuel we consumed to create how many kilowatt hours we get out of this. So I got to get a time. So I don't know when this started. It's been what, five minutes. So we'll look at my PC here. We'll take you out of the gimbal here so you can see that. So it's about 4:25. So we'll say 4:20 is when we started. So I'll write that down, and then we'll get a time on this thing, and we'll see what our fuel consumption is per kilowatt hour. Alright, so we'll see you in a bit. Alright, so I'm back here at the EG4. Alright, so I got the amp meter on the wire leading into the first battery. So I got two of them here. I don't know why maybe I couldn't see it in the first video, but you can see that it's reading negative amperage like it's supposed to, right? So if I turn this off, that negative will go away and it'll read positive, right? So you can see the negative. Alright, so let's kill power. You should hear the generator respond. Okay, so now the batteries are outputting roughly 18 amps. So it went from negative to positive. So I'm going to flip the switch back. I'm going to reload the generator. Sorry for the unstable hand. Cut down to nothing. Now the charger is going to apply the load back into the batteries. Now we're going to ramp up. Takes a minute. And that kind of fluctuates too. Just to get into the light here so you can see that. Alright, so now it's charging. Just wanted to show that better, just so you can see that first attempt wasn't a good display there. So, but anyways, we're a little over a half hour into the run. Suppose we can go check on the water drip system. So I'm gonna pause and walk out there. All right. So we're back outside. Take a look in here. Alright, so you can see the water's coating that nozzle nice and even. That's what we want. Of course, I prefer that to be pure steam, but it's not fully up to temp, so it'll start processing the water better as it heats and we go through the run. But so far it's working, and that's actually working a lot better than the old drip system. Yeah, I haven't had to muscle that valve or anything, so that's one of the main goals, is to get this to where it can self-sustain without any intervention, and we pretty much achieve that. All right, so I'm gonna just keep letting it run and come back here and there and see what it looks like. So we'll see you in a few. Hey guys. Alright, so I'm trying to work on my sound, because like when I have this in the gimbal versus me carrying the camera, the sound is hard to control when I do get it into a video editor. But anyways, I hope I'm not like blasting your ears out at times, but sometimes I gotta speak louder when I get closer to that generator. But anyways, I haven't changed the flow rate, and it is now seeming to be fully evaporating now. So So we're gonna take a peek in here. Right? So what I'm gonna do is I'm gonna turn this up. Now I'm not gonna fiddle with any of this to try to get it to flow. I'm just gonna turn up the rate. Oops, I might have went too much. Alright, so I'm gonna go back to a half a turn. Might have overtooled it. It's kind of percolating. You heard the generator change, right? Oh yeah. So you can see the valve position. Seems to be good. But you see how much I can move that valve? It's not as finicky as a wood gasifier. You can't do that with a wood gasifier. Not at this scale. I might be overdoing it though. Kind of. No. Alright, so it's kind of dried back up. Alright, so I'm going to turn it up again. The fudge. I know it's hard to stand there with a stupid camera. Alright, so it's staying pretty wet. Yeah, that thing's running really strong. And I'm running a slightly heavier load than I was before. So, anyways, I'm gonna let that run. I got a loose dog, so I gotta go track her down. So, I'm gonna go get her, and then we'll come back a little bit later. All right, guys. So we're back at the machine again. Just wanted to show you this guy. So I think that check valve was the missing ingredient, because it's working exactly how I thought it would. Steam pressure builds, blocks that off, pressure decreases, water flows in, and then repeat. Now you don't have to come out like what I'm doing here. I'm just trying, if you want to get the most out of it, yeah, you want to try to get as much water flow as you can. But you don't have to. I mean, you can leave that at a quarter turn out and be fine. Yeah, I'm afraid to turn it up anymore. I think I got it pretty good. I'm just gonna leave it where it is. Right now it's about 3/4 of a turn open, and that's the most I've ever had one of these open.
actually. I think the old style I was able to open about a quarter turn, and at times I've tried a half a turn, but I think that was too much water. It left the nozzle a bit too wet, but as you can see how it evaporates? That's what we want. We don't want it constantly wet. The evaporation is actually what's cooling that jet, or partially. So that's working really good. That is just awesome. So right now, I think it's 6 o'clock. So it's been running a little over an hour and a half. And usually by this time, that's when the machine starts giving you some trouble, and you'll have to make adjustments. It's basically at the end of the hopper load. But we'll see. I'm not going to try to predict. I'm hopeful we'll get 3 hours. But, well, I guess we'll just have to wait and see. But well, we are running at 500 watts more than what I did on the previous run. So that runtime may change. So I'm gonna have to do follow-up runs at this load. So I'll probably do like three runs at this load with the 30 amps, and then see how see if it'll repeat. But yeah, like I said, it's 6:05 now, so we're well beyond an hour and a half into the run, and it's been running just rock solid. So we'll have to wait and see what happens. So we'll be back. All right, guys. So we're rolling up about 6:40. So we started at 4:20. And it is now about 6:40, so that's 2 hours and 20 minutes. I was hoping to get another 10 minutes out of it, and it would make it 2.5 hours. But then again, we are running an extra 500 watts than we were before. But it actually could probably still keep going. So we're about 28 amps still. So yeah, it just kind of died out. It's actually starting to get unstable, which is typical. It's just the way it is with a gasifier. I don't know, it seems to be running pretty good now. Dry as a bone in there. Turn the valve up just a fudge. Hoping it's not too hot for this check valve. But I can see steam blasting out of there. If you get the right angle, you can see it. I don't see it right now. But I'm pretty sure if it's not ejecting steam, it wouldn't be running. Or at least not as strong as it is right now. And there is a vent on the back of the tank. We CNC machine that.
So you see the steam venting out. So the water is actually boiling in that tank, which is fine because it's preheating the water before it goes into the nozzle. That's actually by design. You see it's kind of dying down. Do a little adjustment there. I don't know, I'm just gonna let it go. But I see like a flickering, you know? The flickering is the steam. Just for kicks, I'm gonna turn this valve up. I'm gonna go full. Now it's at 2 full turns open. You gotta be careful though. If you blast, when it's this hot, you blast it with water, it can flash back. And now it's running good and strong again. Shit, I'm gonna leave it. Okay, never mind. We're just gonna keep going. Okay, this is crazy. So this is 3 hours. I've never seen one of these machines run 3 hours on a single hopper load. But I have a feeling the plastic check isn't working. So actually, I gotta find the gimbal because I'm gonna need to put you on it. And I'm just gonna try to quickly swap that out with this aluminum one. But this thing won't stop. And I swear to God, I haven't put any more fuel in this, only water. It actually consumed that whole five liters of water. But like I said, some of it is boiling off and venting out. So I don't know how much is that. I don't know what that rate is. Man, what did I do with the gimbal? Alright, well, hold on. I'm gonna put you on pause here. Alright, so I don't know if I'll be able to get any more. But I'm gonna sight you down. See what I'm doing. Alright, so I think it's done. You can hear it steaming. It's doing what it's supposed to do. But yeah, we're gonna go to the aluminum. I was hoping that little skinny one worked because I got kind of limited room there. But we'll go ahead and cap it off and open the flare cup vent. So 3 hours. And running at a higher load than we were before. That's nuts. And then, you know, like I said, I'm not buying that it consumed the full 5 liters. Some of it boiled off, but I have no idea how much. Alright, so I'm gonna let this cool down a little bit and take a look inside. See if it consumed the 10 gallons or if it consumed more than that, because sometimes that is a possibility. So I want to verify that first. And I'm just going to look in there just to see if it's at the ribs. If it's at the ribs, that's 10 gallons. I know that for a fact. But we'll figure that out, and then we'll do some number crunching and figure out how many pounds it consumes to create one kilowatt hour. All right, so we'll be back, guys. So we're gonna take a peek inside here. It's still pretty hot. It's actually hasn't been that long since I cut the last video. So stand back, because I did get a nice poof back, but you can see the rib exposed, and I flattened that out. So yeah, it consumed 10 gallons, maybe a little heavy, but I mean, we're not trying to big exact. I mean, it's about impossible, but so 10 gallons, and a gallon weighs roughly a pound of charcoal. All right, so now we're gonna do a little number crunching. Let me know if I've done it wrong. I suck at math, but all right, so our inverter output was 800 watts, actually about 850, but I'm gonna call it 800. The charger, I'm using 27 amps because it did fluctuate between 26 and 30. So it was about 27, 28 average, but according to this, my backup inverter, this tells me I don't know if you can see that. Chris has got his, but it was charging about 55.6 volts or something like that. So I'm calling it 55 volts. Okay, so, and that's 1485 watts plus the 800 brings us to 2.3 kilowatts. And then we had a 3-hour runtime. So our net total kilowatt hours is 6.9 kilowatt hours. And we could round that to 7, but I'm going to use the 6.9. So 10 pounds of charcoal divided by 6.9 kilowatt hours equals 1.45 pounds of charcoal to create 1 kilowatt hour net energy output. So that is pretty good, I'd say. Let me know what you think in the comments, but we're going to conclude this, and of course we're going to continue to test. And actually, I may modify that water tank, because there's no sense in letting that steam just vent to atmosphere. Why not reclaim that too? And that's actually a pretty simple modification. Basically all I got to do is drill a hole in the bottom of the tank and put a tube that extends up to the top, maybe along the back here, and then I'll plug weld the actual vent. And then what we'll have is the pickup tube, and then that will go And then we'll have a hose that goes from that pickup tube into the nozzle as well. So when it starts venting off steam there, we'll reclaim that too. And the more steam we can get in there, as long as oxygen can still get in there, but that's the whole goal, is to reduce the atmosphere. As long as we can still create the process heat, that's more steam that we can convert. And then it's more efficient to convert the leftover oxygen, because that's actually the process. It's not, we're cracking the water, but differently than like electrolysis or anything like that. How this works is the carbon is reacting with the oxygen, and at that temperature the bonds are weak. So basically the carbon is ripping the oxygen away from the H2. So the oxygen is never free. It's never it can't be consumed through oxidation process. It's going from hydrogen directly to carbon and creating CO. So that's a more efficient conversion than the oxidation process, because you have anytime you're doing an energy conversion, there's a loss. So when you have the atmosphere, the oxygen in the atmosphere is oxidizing the fuel, creating CO2, and then that CO2 is processed downstream, basically the same way. The CO2, the carbon is reacting with the oxygen and the CO2, and ripping it away, creating CO and leaving CO. So okay, so we're going to conclude this now, and then we'll be doing some more testing. I think that's going to be my next step, is adding that additional vent and testing that out. And then, I guess if it don't work, and then, I can always weld that up and drill a new vent hole. Not a big deal, but definitely worth a try. Yeah, we're making some killer progress here. This machine is just plain awesome. All right, guys, so we'll see you on the next one, man. Thanks.